So it looks like we're about to do some graphing. In fact, we want to write the equation in polar form and sketch the graph of the conic with the following characteristics. E equals 1/3, and it has vertices at -2, 0, and at 4, 0. So let's think what we have. We know that the characteristic is, we know that the eccentricity is at 1/3, which is less than 1. So E is greater than 0, but less than 1. Therefore, we know we're looking at an ellipse. We also know that the vertices are on the pole or the horizontal axis, which means that we're looking at a cosine function. Some cosine, let me put that in quotes. We're looking at some cosine function. So the general form of this equation should look like, in the end, R equals ED over 1 minus E times the cos of theta. Now I bet you're asking, how do I know that it's minus? Well, let's look. If I plot these points, -2, 1, 2, and +4, 1, 2, 3, 4, and find the center. Well, the distance from 4 to -2 is 6 units, so if I go backward just 3 units, 1, 2, 3, that puts the center at 1. I don't really care as much that the center's at 1. What I care about is that the center is on the right-hand side of the pole, this being the pole. So the center is on the right-hand side of the pole. That means the directrix is on the left-hand side of the pole. And since I know the directrix is on the left-hand side of the pole, it's a minus. It's on the minus side of what would be the x-axis in rectangular coordinates. So let's plug in everything we know. I know that E is 1/3. I know that D is a negative value, so -D. I know that 1 minus 1/3 cos theta is moving toward our final equation. I also know I don't like these fractions, so I'm going to get rid of them by multiplying everything by 3. So in the numerator, 1/3 times 3 is 1, so I get -D. And in the denominator, I get 3 minus cos theta. So now I just have to figure out what D is. And to do that, I'm going to find a value for R. I'm going to do it in 2 different colors because I'm going to calculate for each of these points. I only need to calculate for 1, but I think it's important to see that it works no matter what the point is. So let's start by finding what would the radius or the R value be for the point -2, 0. Well, this is a rectangular coordinate, x, y. How would I convert that to a radius in polar coordinates? Well, that's R equals the square root of -2 squared plus 0 squared. Well, that's just 2. And the other one, for the other point, R would be the square root, or the distance would be 4 squared plus 0 squared, which equals 4. So it's got to be a little disconcerting at this point when I know I'm going to plug values into here and I want to find D, that I have 2 different radii. But remember, we're talking about an ellipse with a vertex, and the radius is whatever the distance is from the focus, not the vertex, from the focus to a point on the edge of the ellipse. This radius is clearly different than this radius. The magnitude or the length of this line is clearly different than the magnitude or the length of that line. The radius on a conic section, unless you're looking at a circle, is never the same all the way around. So it doesn't mean anything that we got 2 different values for R. We're going to use each one in turn to calculate for the value of D. So I'm going to come over here. And first I'm going to solve for my -D. And so that would be R here. -D equals R times 3 minus the cos of theta. Okay, so if I put the first values in, the brown values, I would have negative d equals 2 times 3 minus the cos of, well, what is theta for the point that gave me 2? Well, that's this point here at negative 2, 0. What is the angle for that point? Pi. So I want the cosine of pi. So that's 2 times 3 minus the cos of pi is negative 1, so that's 3 plus 1. So that's 2 times 4 equals 8. Okay, let's calculate for the other point, this point. Minus d equals 2 times 3 minus the cos of, what's theta this time? The point that led to this radius in conversion from rectangular to polar coordinates, the point that led to it is 4, 0. What's the angle on which 4, 0 lies? Right here. Let's color code that. Well, that's the angle 0. So I'm going to put in 0. And I get 2 times 3 minus, well, the cos of 0 is 1, a positive 1. Yep, I had to stop the video. I'm sure you saw it the second it happened. My pink, I'll just erase everything. My pink function had 4 for a radius. 4 times 3 minus the cos of 0 equals 4 times 3 minus the cos of 0 is 1. So 4 times 2 is 8. Phew! That looked like it was going to go sideways for a minute there, but we're good to go. So I have the same d value no matter what. I have the value that minus d equals 8. I'm looking for minus d. So r equals 8 over 3 minus cos theta. So now we can sketch in the graph. Let's start with the directrix. Remember, it takes the sine and d. So the directrix is x equals negative 8. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Ooh, I was almost off the graph. X equals negative 8. And I have 2 vertices, but I want to know the upper and the lower vertex. And the good news is that it's going to cross over the line pi over 2, or the angle pi over 2 and the angle 3 pi over 2. So I'm just going to plug in values to find those. So if I want to know what's the value at this point, I'm not actually going to find necessarily the vertex, but I could certainly put a value so I know, is it a big round ellipse? Is it a really super duper skinny ellipse? What's the value? So I'm going to put in r equals 8 over 3 minus the cos of pi over 2. And that's 8 over 3 minus 0. So it's 8/3. So let's see if this is 1. Well, 8, I'm going to need, I'm going to need a mixed number. So that's 2 and 2/3. So that would be at about there. And on the other end, r equals 8 over 3 minus the cos of 3 pi over 2. Good news, I get 8/3 again. So 8/3 again, we might be a little disconcerted that I get a positive value, 1, 2, and 2/3, that I'm getting a positive value out. But remember, on a polar graph, we don't want to see a negative in this case, because the negative would tell me just to plot right back to here again. So this would be my ellipse if I were to sketch it in. It's big and fat, almost circular it seems. And of course, if I wanted to know where another value is, I could use some other calculations, but I think that's close enough for me to sketch that in, even though it's not pretty. Let's do it this way. All right, let's do another example. This time, we only want to write the equation in rectangular form, but it's still helpful to have a graph so you can see what you're doing as you go. So r equals 30 over 4 plus cos theta. Okay, so first things first, we know because it's cos theta that our polar axis is the major axis. So in polar form, it's the polar axis. And in rectangular form, it's the x-axis. That means that it's whatever shape it is, the widest part is on the x-axis. So first, let's get it in the right form. I'm going to divide everything by 4. I don't really like it, but it's what I'm going to get. 30 over 4, 1 plus 1/4 cos theta. And so now I know 1/4 tells me that E is bigger than 0, but less than 1. And so the shape I'm going to end up with is an ellipse that's longer on the x-axis and shorter on the y-axis. Since we're technically not graphing, I'm not really going to need the directrix, but I'm going to give it a shot anyway. So I know that E times D equals 30/4, and E is 1/4. So 1/4 times D equals 30/4. And so D equals 30/4 times the reciprocal, 4 over 1, 4's cancel, so D equals 30. Again, I don't think I'm going to need it, but I have it just in case. So the next thing I want to look at, I want to kind of see where it lives. So I'm going to look for these two vertices. So I know I'm looking at the angle. This is polar coordinate, so I'm going to have to work with angles. The angle 0 and the angle pi. I'm going to plug into the original form. R equals 30 over 4 plus the cosine of 0 equals 30 over 4 plus, well, I'll write it out. The cosine of 0 is 1. 30 divided by 5 is 6. So 1, 2, 3, 4, 5, 6. And then R equals 30 over 4 plus the cosine of pi. 30 over 4 minus 1. So that's 30 divided by 3, which is 10. So R equals pi is at 1, 2, 3, 4, 5, 6, 7, 8. Darn, I'm not going to have room. So let's see, 2, 4, 6, 8, 10. And let me move this one. 2, 4, 6. Okay, next thing I want to find, using these points, I want to find the center. So the center HK is going to tell me where I can put my rectangular translations on the rectangular form of the equation. Let me write that down. X minus H squared over A squared plus Y minus K squared over B squared equals 1. So this is what I'm looking to switch to by getting all the information I can from the original form. So I have, if I can find H and K, then I can plug in H and K. Well, HK is the center. There's no translation up or down. We can see that the vertices are exactly on the polar axis or the x-axis. So halfway between 10 and 6 is 8 units away from each. So 10 take away 8 would be at 2. 4, 6, 8, 10, yeah, or at -2. So the center in polar coordinates is at 2 pi, and the center in rectangular coordinates is -2, 0. And this is the one we want, so I can go ahead and plug that in. X minus -2 is +2 squared. Remember, X and K are cattywampus, plus Y minus 0 is Y squared. A squared over B squared. So this is all I need to find is these A squareds over B squareds, and then I can write out the entire formula. Well, where are we? First, on the x-axis, A is the distance from the center to each vertex. And so that distance is 8, and it's true on both sides. 8. So I can substitute 8 for A. So now we're getting somewhere. I'm going to take out this 1 on this side because it lets me use my space a little more effectively. 1 equals all of this, but that equals x plus 2 squared over a squared. 8 squared is 64, plus y squared over, I just have to find b, and as soon as I have b, then I can just plug that in there and I'm done. So how am I going to find b? Well, it'd be nice if my center was at the center or at the pole, because however high I have to go to the upper and lower vertex, that would give me b, and I'd be done with it. But I don't have that. My center is off, and so I can't just plug that value in. So I'm going to need a way to find b. So to do this, there's a formula that's worth memorizing, but first, let's talk about why the formula exists. So the vertex, the upper and lower vertex, are someplace above the center. So I'm just going to put a circle here. I don't really know where they are, but I'm going to put a circle to represent wherever they are. Well, since we found the center and all of our other values by using the polar form of the equation where this number is a 1, we know that one of our foci is at the pole, or 0, 0 on the rectangular coordinate plane. And the other thing we know is that from the center, the foci are split right in half by the center. So if I go 2 units from the center to one focus, then it's exactly two units from the center to the next focus. And then remember, when we sketch out an ellipse, we have 2 foci and a string of some length. We attach the string one end to each focus and put a pencil or a pen here and then start to trace around. And you're constricted by the length of the string all the way around, and so this is how the ellipse gets drawn out or sketched out, and it works all the way around that way. So if we want to find the length of the string that it would have taken for this ellipse, all we have to do is trace from one focus to one vertex and back to the other focus. So in this case, if I go from the first focus all the way across to a vertex, well, I'm going 4 units plus 6 units, that's 10 units, and then I'm going to turn around and come back to the other focus, which is only 6 units. So I have a focus, or I have a string that is 16 units long, and that's handy because since the center is right between the 2 foci, whenever I make my upper and lower vertices, then what I do is I split the string exactly in half. And so 16 divided by 2 is 8. And so each of these string lengths are 8. Now, that means I can make a right triangle right here, because what I'm looking for is this height, the height directly above the center to the vertex. And then of course the same height will exist on the other side. So if I sketch out that triangle, it's a right triangle, and B is the height I'm looking for. I know the hypotenuse is 8, and I know the base is 2 units. And so 8 squared equals B squared plus 2 squared. B squared equals 8 squared minus 2 squared, which equals 64 minus 4, which equals 60. So I have b squared equals 60. Now I could keep going and take the square root of 60, but I don't need to because I'm actually looking for b squared, right? To go under my y, b squared. Well, b squared equals 60. Plug in 60 equals, I'm just going to bring this 1 back over, and this is my rectangular form of my polar equation, r equals 30 over 4 plus cos theta.